Let us start lecture 26. The course is phase diagrams in single component and binary systems. And today we will try to complete the discussion on enthalpy of free energy mixing. That means mixing free energy before and after mixing, that is the change of free energy, and mixing entropy. These three things we would like to calculate. In fact, in the last lecture we have already found out the enthalpy of mixing when we mix multiple ideal gases in a closed system and a fixed composition. We saw that that particular contribution is nil actually. So, physically it means that the interaction among the molecules of that gas is nil. Okay. Our topic is ideal gas mixture and calculation of del Hmix, del Gmix and del Smix. We have already found out that del Hmix equal to 0. Okay. And where from we started? We have started from this equation. And we have taken help from Gibbs-Helmholtz equation, which says so we have taken this help from this equation and we have applied this onto this and then we have found out this. Now, we have to find out what is the value of delta G mix. And when we try to do delta G mix, we will start with this equation, rather we will change this equation a little bit. G I bar equal to G I naught plus R T ln P I. So, we will take this. In fact, this is for mix and if we do not mix it before mixing, we can also calculate that. And here P is written in capital letter. So, this is for pure gas. So, we will take these two equations and both the cases. So, this is the standard value, this value as well as this value both are equal and these are for pure gas when the pressure is 1 atmosphere. Now, when we try to find out, and remember this is closed system and here what we are doing, we are fixing temperature. So, that means at a particular temperature we are trying to find out what is the mixing free energy before and after mixing, okay, that is the change. And of course, when we do that, we try to calculate free energy change, which is basically G 2 minus G 1 and remember here one more thing, which is fixed composition. We are also fixing the composition. Now, this second stage is basically, which is the second state, is the mixed state and first state, which is state 1, is unmixed. And G is extensive quantity. So, we can write this as delta G and I can put a mix equal to Ni Gi bar minus Ni Gi. And this is a summation. So, that means we are taking a large number of gases and every gas has certain number of moles which are added together. Now, we can use this two formula outside, then I can write Gi naught plus RT ln Pi minus I can write this. So, these two quantities will get cancelled because these are for standard state for individual gas. So, then it becomes fine. So, this is mix, we get this. We have to deal with this particular quantity. Now, let us say before mixing each gas has some pressure, okay, and all those pressures are equal. So, that means Pi equal to Pj equal to Pk. So, I, J, K are all the individual gas components. And also when we are mixing, after mixing, we are saying that total volume is basically summation of individual volume. Okay. So, that if we have that situation, then I would come up with this, that P I equal to P j equal to P k equal to P mix. So, this P mix is nothing but pressure of the mixture, and that time the total volume is constant, okay, which is basically a individual volume we have to consider. Fine. So, now I can write Pi Vi before mixing equal to Na RT, and P mix V total should be equal to Ni RT. I can write that. So, remember this P is basically every time is a capital P. Now, so from I can also write small pi Vt should be equal to NART. This is for mix and this is for mix again, and that time small pi is basically partial pressure of ith component in the mixture. So, in fact, if we try to look at this equation, this is before mixing. So, we can actually show whether this has to be taken. So, total volume, let us say I am taking total volume as Vt. So, we can prove whether this P mix would be equal to the individual gas pressure before mixing. So, if I let us say there are 3 gas components or 2 gas components. So, let us say 1 A and B, these are the 2 ideal gases. This ideal gas equation of state is P A V A equal to N A R T, because we are starting with any number of ideal gas A before mixing. So, then I can write V A equal to N A R T by P A. Similarly, I can write for B gas V B, the volume of gas B equal to N B R T by P B. So, this is one equation, this is second equation. So, then I can write V total equal to V A plus V B equal to N A R T P A plus N B R T P B. And now, if P A equal to P B, so then I can write V T should be equal to N A plus N B R T and equal to P mix, it should be P mix. So, that means V T is basically the total volume considering individual volume to start with at that temperature T, and when another condition is individual gases, that pressure would be Pi equal to Pj equal to Pk, like that way, and that will be equal to P mix, which is the pressure after mixing. So, that case this volume, total volume should be constant. So, that means individual gas volume to be added up. So, from here, and also this is for mix, we have already seen that before, then I can write Pi by P mix should be equal to Pi by capital Pi should be equal to Na RT divided by Ni RT. Here please change it to Ni because this is the ith component. So, this is I, please change that. So, this quantity should be equal to Xi and these two quantity would get cancelled. So, Pi by capital Pi should be Xi. So, now we take this particular formula, then we get delta Gmix equal to okay. So, from there we are getting Xi, okay. And here we can write this because capital Pi equal to P mix. So, we are getting this formula. Now, interestingly, if you see here, Ni is a positive quantity, R as well as T both are positive, non-zero value. Since it is Xi and Xi is a mole fraction in a mix, has to be less than 1. So, this is negative. It means that delta G mix should be negative. It also suggests, this means physically it means that mixing of ideal gases is a spontaneous process, okay, because free energy of mixing is negative. So, let me just calculate delta S mix. In order to calculate that, we can make use of this formula. So, here we mean that again closed system, constant temperature at a particular temperature T, And of course, we are also fixing pressure. Remember, we are also fixing pressure. So, we are only trying to see what is the change due to mixing of multiple gas components. And when we do that, we do not consider any reaction. We are also fixing that the composition is fixed. So, there is no change in the composition. So, P, T and composition all are fixed. So, that is what we are only considering the mixing term. Here also this is applicable, remember, here also this is applicable, same condition applicable. So, now we can say we have already seen that this goes to 0. So, then it is basically minus T del S mix. So, delta G mix we have found out is equal to minus T delta S mix. So, then delta S mix is equal to where T is non-zero value. So, that means it should not be 0 Kelvin. So, that case this goes to this and with a minus sign. Now, let us see again, this quantity is positive, this is positive, Xi is less than 1 in a mix. So, then this must be positive. So, it means that entropy increases due to mixing. Okay. So, entropy increases due to mixing. So, now we could see that finally, we could see that for ideal gas mixing, delta H mix equal to 0 and delta S mix equal to Xi. So, this is less than 0, this is greater than 0. So, now we could see that 3 equations we get, del H mix equal to 0, del G mix equal to less than 0 and del S mix greater than 0 for the ideal gas mixing. In fact, we can also prove this. Molar volume before and after mixing, that del V mix is also 0, but for this we will try to get into one concept called Raoultian solution concept. So, and also try to see how the Raoultian solution concept or Raoult's law when we try to look at, then we will from that we can also prove this, that delta V mix is equal to 0. So, let me just stop here. We will continue our discussion on this mixing free energy, mixing entropy as well as mixing enthalpy. Now, what we will do, we have got an idea about these quantities, mixing quantities when we talk about ideal gas mixing. Now, we will go to condensed system. So, condensed phase solution is nothing but the liquid solution or solid solution. So, in order to understand that, we have to bring in few concepts related to the solution formation, like Raoult's law as well as Henry's law, and then we will take our discussion to the formation of solution considering the equilibrium in vapor phase. And when we talk about equilibrium in vapor phase, we will take consideration of saturated vapor pressure of individual component in a solution. Okay. So, till then let us stop here. Thank you very much.